Hi there, guys. Today we're going to be looking at some systems of equations and really diving into what a system of equations is. And then you'll really be working on solving those systems by graphing. So that's kind of our main goal for today. So first I want to walk you through these notes so we have an idea of what we're doing. So first off, what is a system of equations? So a system of equations is two or more equations that have the same variables. So these equations generally have things to do with each other, and we'll see that a lot in this unit because we're really going to be looking at some word problems because that's where this math really comes to life. So we're dealing with two or more equations that have the same variables, and that's a really important piece, so we have to have the same variables. So when we graph this system, the point where the two lines intersect is one of my solutions. So when I'm graphing them, I can see that they intersect or they run into each other at one point, and that's going to be my solution. So algebraically, when I actually solve them, and we'll learn several ways to solve them, the point x, y makes both equations true. So if I have that x and y value, I can plug it into both of my equations and make true statements. So there's three different types of solutions that I can have. I can have intersecting lines, which is what most of our equations are going to look like in most of our systems. That's just where when I graph them, I end up with two just lines that cross somewhere. So then I would see I would have my solution right where they touch or they intersect. Another type is I would have parallel lines. And here they have no solution, right? Because if these lines are parallel, that means they will never touch, which means they don't have a solution. The thing I know about parallel lines is they have the same slope. Okay, so that's really important. But the other thing that parallel lines have is they have the same slope, but they have different intercepts. Okay, so the third type of solution I could have would if they would be the same line. So if I graphed two equations and they ended up being the same place or the same line, I would have an infinite number of solutions. So very similarly to my parallel lines, I would have the same slope, but I would also have the same intercept because they're the same thing. So how we can solve these by graphing, there's some different steps that we're going to be taking. So the first step that we're going to be doing is to get both equations, right? Because we're dealing with more than one equation. So get both equations, and I abbreviate equations as EQN, in y equals mx plus b. Okay, so that's my slope-intercept form. So first thing I get it, so both of my equations look the same, y equals mx plus b. The second step that I'm going to do is I'm going to graph those. Right, and if you need a refresher on how to graph something in y equals mx plus b, so first step, I graph b, I graph that point on my y-intercept, and then I use the slope to find some more points. So I graph those two things. And then my third and final step is I find the intersection point. So if I'm given just two equations, my final answer will be in something that's like x comma y. It will be in a coordinate plane. When we get to our word problems, you'll start to see the actual solution. You're going to be answering a question, so we have to make sure we're answering those questions. So now let's try a couple together. Okay, so here in number one, the first thing I notice is that both of my equations are already in the right form. So I'm going to go ahead and graph them. So I see this, I have y equals x minus 8. So the first thing I plot is a minus 8, 2, 3, 4, 5, 6, 7, 8, and I put a dot there. And I have a slope of a positive 1. So my first equation, and I like to use color when I'm doing this, it's not something you have to do. And my other equation is this negative 2x plus 1. So I have my plus 1 and a slope of negative 2. So you'll see I have the purple line. Then I can find my intersection point, which would be right here. And my intersection point is at 3, comma, negative 1, 2, 3, 4, 5. And I want to go ahead and include that. So the other thing I can do is I can double check the work that I've done so far. So I take this solution that I have and I plug it back into my equations. Okay, so I'm going to plug that negative 5 in for y and 3 in for x And see, here I end up with -5 equals -5. That's a true statement. So let's try it in the second equation. So I've got -5 equals -2 times 3 plus 1. So -5 equals -6 plus 1. So again, -5 equals -5. So again, since I have two smiley faces here, that tells me that it works for both of those. So I was correct in my solution. Let's look at one of these examples that doesn't have my equations already figured out for me, because that's always going to be the first step. Let's look at number 5 here together, and then you'll have plenty of time to go through and work on these other examples, and I will post the solution set to those, and then you can go ahead and work on the homework. Okay, so first I see that the second one is already in a form that I can graph. So I see I've got y equals -7. So remember, I don't have any slope there. So I'm just going to go to my -7, 2, 3, 4, 5, 6, 7. And my line is not a very straight line, but your goal is to be very straight. Okay, so there's that green line. Well, my other equation, my purple one, I see is not in the correct form yet. So I'm going to have to go ahead and solve that first for y equals mx plus b. So if I've got x plus 3y equals -15, the first thing I do is I subtract that x from both sides. So I end up with 3y equals -x minus 15, and then I divide everything by 3. So I end up with y equals -1/3 x minus 5. So now that I'm in slope-intercept form, I can go ahead and graph. So I put my dot, and then I have a slope of a -1/3. Okay. Whoop, that dot should be there. So I can see that my line is going to go this way. So I do see that I will eventually have a solution for these two. It's going to be way over here somewhere. So I can't really find this one by graphing. We will get to the point where we can solve this another way. So what I'm really looking for in this homework and this work is that you've graphed both equations on the same coordinate plane, and you've circled or put a star around or highlighted or something the solution if you can see it. Okay, so now here there's several other examples that you can go ahead and try. I will go ahead and post these answers so that you can double check and make sure you're doing it right before you jump into your homework. And so right there, that's all of our information for section 1 and learning how to solve these solutions by graphing.